Solving radical equations, day 2. Alright, stick with me on this stuff. It gets a little bit confusing, so make sure that you're understanding what's going on while we're going through this. Same as yesterday, we're going to complete the odds as the notes, and the evens will be what you're responsible for when you come to class. So please come prepared to share what you have done and work through the problems that you got stuck on. Both are mirror images, so you'll see similarities between 1 and 2, 3 and 4, so on and so forth. So the first thing we're looking at here is we're looking at isolating the radicals on either side of the equation. So once we get into the later numbers, you're going to note problems. You're going to notice that there'll be other numbers with them. That's okay. We just have to know what to do with them. So since these are isolated already, we'll go ahead and square both sides to get rid of the radicals. 2m minus 6 equals 3m minus 14. I'm going to bring the 2m over as well as the 14 at the same time. This will cancel. That will become 8. That's 1m, and that cancels. As usual, please check for extraneous solutions using the Boolean algebra, graphing, and finding the intersection, or simply plugging 8 back into the original equation. Question number 3. Now notice there are numbers outside of the radicals. They are being multiplied. Pay attention because later on there will be addition and subtraction, which changes the problem slightly. Please remember you must isolate the radicals on either side of the equation, and then we're going to square both sides of the equation, including the numbers that are in front of the radicals. Remember from our properties of exponents, that means I'm going to distribute the 2 to the 4 as well as the radical, and the 3 and then the radical, making this 16 times x plus 1. 4 squared is 16. The square root of x plus 1 squared is x plus 1. That's 9 times x plus 2. Using the distributive property, I'm going to get 16x plus 16 equals 9x plus 18. Now I'll go ahead and solve this. 9 coming across, the 16 going across, and I get 7x equals 2. Divide by 7. X equals 2/7 is your answer. Please make sure you're checking your extraneous solutions. Okay, question number 5. Notice in this question they are not isolated. They're both on the same side. The easier way to solve this problem is first by moving the square root of y minus 2 to the other side of the equation. Now note, you could have squared both sides to begin with, and you will get the same answer. It's just easier to start by moving this to the other side of the equation first. The square root of 4y plus 1 is going to equal 3 plus the square root of y minus 2. Now this is going to challenge your factoring skills, so please make sure that you are factoring these appropriately. One misstep is going to give you a really different answer than the correct one, okay? So now that my numbers are isolated, or my radicals are isolated, now what I must do is square both sides, including the 3 and the plus sign. Now what I notice I have here is a binomial, okay? Now this binomial is no different than x plus 2 squared. So let's review that really quickly so we know what we're doing. This is a perfect square trinomial. X squared plus 4x plus 4 is this number multiplied out. Likewise, this number is solved the same way. So this is 4y plus 1. Now I'm going to do 9, that's a squared, plus 6 times the square root of y minus 2. That's 2 times 3 times the square root of y minus 2. Now you can see why it's challenging your ability to factor, because the numbers are getting very abstract. And that's b squared. Okay, Next step is to combine like terms, so I get 4y plus 1 equals 7 plus y plus 6 times the square root of y minus 2. The next thing I'm going to do is subtract both the 7 and the y to the other side of the equation. And I get 3y minus 6 equals 6 times the square root of y minus 2. If I divide out the 6 right now, I can reduce this down to what it is. It'll be 1/2 y minus 3. However, that will give me a fraction in my leading coefficient of y, and I don't really like to deal with that. So instead what I'm going to do is I'm going to square both sides to get rid of the radical symbol. Okay? Now the reason why we're doing this is because it's impossible to solve this problem without first getting rid of the radical symbol. That's why we're squaring both sides. See how it's getting complicated because we're doing multiple forms of the perfect square trinomial, and we're doing it sometimes with radicals and sometimes without. Okay, so over here we get 9y squared minus 36y plus 36. On the other side we get 36, that's 6 squared, times y minus 2. I'm going to distribute that through, and that's going to give me 9y squared minus 36y plus 36 equals 36y minus 72. I'm going to move both of these numbers, 36y and 72, to the other side of the equation. And now I have a factorable form, y squared minus 72y plus 108 equals 0. Before moving on, I'm going to take out the GCF, which is 9, okay? And that's going to give me y squared minus 8y plus 12 equals 0. Factoring that out, what two numbers multiply together to make 12 and add up to 8? That's going to be 6 and 2. So that's minus 6 and y minus 2. My solutions are y equals 6 and y equals 2. Checking for extraneous solutions, they both work. That one's the most complicated problem on the entire notes page, so look carefully at it before moving on. Question number 7. Alright, it doesn't matter whether the index of the radical is 2, 3, 4, or 5. We're simply going to raise it to whatever power it takes to get that radical to go away. So we'll be cubing both sides here. X plus 2 equals x over 2 plus 5. I'm going to move the x over 2, and I'm going to move the 2. That's going to give me x over 2 equals 3. Multiply both sides by 2, and x equals 6. Remember to check for your extraneous solutions. This one checks out. Alright, we're changing from radicals into rational exponents. Either way, it is the same. We're going to look at this and raise it to its reciprocal power, or if you're more comfortable, change them back into radicals. Either way, it doesn't matter. However, notice over here on the right side of the equation there is a negative exponent. So before we're going to get rid of these exponents, we've first got to rewrite it so that it's in its proper location. So I'm going to write it as 3x plus 2 to the 1/2 power. The 8 has a positive exponent, so the 8 stays on top. 3x plus 2 has the negative exponent, so it will be moving to the bottom, and that exponent will become positive. Now what I'm going to do is square both sides to get rid of that rational exponent. And now I get 3x plus 2 equals 64 over 3x plus 2. Multiplying both sides by 3x plus 2, and now I can solve for x. So that's going to be 9x squared plus 12x plus 4. And that's all equal to 64. Subtract your 64 to get your factorable equation. And now I'm going to solve. 9x squared plus 12x minus 60 equals 0. Has a GCF of 3. So I'll reduce that to 3x squared plus 4x minus 20 equals 0. Now I'm going to split the middle term by multiplying 3 times 20 to get 60. Find the factor pairs of 60 that will add up to or subtract to make 4. That's going to be 10 and 6. So that's 3x squared plus 10x minus 6x minus 20 equals 0. 4-term grouping. Take out your common factor of x. 3x plus 10. Take out your common factor of negative 2. Leaves you 3x plus 10. And now I've got x minus 2 and 3x plus 10 equals 0. I'll have x equals 2 as one solution and x equals negative 10 over 3 as my second solution. Checking for extraneous solutions, 2 works, and negative 10 thirds does not. All right, question number 11. Okay, in this problem, you can start by squaring both sides, or you could put the simple radicals on the same side of the equation. Okay, either way, it doesn't matter, because either way, you're going to have radicals on both sides of the equation. I'm going to go ahead and leave it as it is and simply square both sides. Now in doing that, I get k plus 9 minus 2 times the square root of k times k plus 9. Now let's look at why that is real fast. Remember, it's 2 times a times b. This is a and this is b. Since they're both under a radical, you can write them under the same radical since it's multiplication. So that's why I write it as k times k plus 9 underneath a single radical. And then I'm going to add k, because that's b squared. And that's all equal to 3, the square root of 3 squared. Now I'm going to simplify by combining like terms. 2k plus 9 minus 2 times the square root of k squared plus 9k equals 3. I'm going to move the 2k and the 9 to the other side of the equation so that I can isolate this radical right here. Subtract 2k, subtract the 9, minus 9 and minus 2k. I get negative 2 times the square root of k squared plus 9k equals negative 6 minus 2k. Notice how this one's different from the previous example. If I divide out the negative 2 to the other side of the equation, all of these become whole numbers and I switch all those negatives to positives. So rather than squaring both sides right now, I'm going to divide out my 2. So now I get the square root of k squared plus 9k equals 3 plus k. Square both sides to get rid of the radical so we can actually solve for k. And over here I get k squared plus 9k equals perfect square trinomial 9 plus 6k plus k squared. Your k squareds cancel out, and now I'm going to move my 6k to the other side of the equation. And solve for k. K equals 3. Check to make sure it's not extraneous. And there's your solution to this problem. Like I said, please make sure you're working on the evens. Come prepared tomorrow to discuss how you got your answers, or to work with your partners on the places that you got stuck. We need to make sure that we understand how this works. I realize it's complicated algebra, so it will take some practice to get it right. Make sure you're ready to share your answers tomorrow in class.